Hello everyone. So we'll start a new session of Python learning. So let's open our book. We have already covered the data types. So today we'll start with the data structure. So in the data structure we are talking about in C we call array, where we can have more than one element. uh, and there are different kind of array, or if we can call it, where we can store different kind of data. So we'll store this in Colab to play with it. So one major array type, if we can call it, is the list. So in this list, it's defined by the square bracket. So it start with the square bracket, and you can have different element. Now you can see we are defining a variable, which is a list which has different content, and the contents are the string. So like we have the name or something you can define. We are printing the a, and you can see the value of it. Then we are defining another variable b, which is again a list, and here we are defining different integers inside it. You can print it. But the most important part of the list is, you can see the variable c, where we have integer also, we have the string also. So the benefit of list is you can have different kind of data type. You can have integer also, you can have float also, you can have the string also. It becomes very useful when you are reading a data and you don't know about the data type. So if you are, let's say, reading from a CSV, comma separated value, or some text file, you can read it and you don't have to worry about the data type. The same list can hold the different kind of data type. So it's very useful and very commonly used data structure in Python. If you want, we can try some other variable where we have, let's say, we have some integer, we have some string, then we have, let's say, some float, complex number, we have, let's say, some float also. And now let's try to print it. It takes time, let the output come. Now we have the different element in this list. How do we get value of one element? So we call it indexing. So we can index our list and we can get the value one. So you can see the d is printed here, and it's holding the complex number also. So here the first element, the index for it is the 0, not 1. So if you want to see the variable a, ram is index 0, then 1, then 2, and then 3. We have one more advantage in Python. The last index is called -1 also. So the same thing can be defined like, -1, -2, -3, -4. So you can see we are printing A0, which is the first element. You can see it's Ram, then A2, 1, 2, this is Bangalore. Then we are printing A-1, which means last element. So this is Delhi. So we can print, let's say, -3 also. So minus with 3 we know, -1, -2, -3, so Sita should come. Yeah, this is coming. So it becomes very useful when you don't know the length of the list. You can start with the -1, -2. Of course, it's not a very big deal to get to know the length of a list. There are very simple functions like length. It's called len in Python. So we can use, but it becomes much more user friendly to quickly indices from the last array, last, second, last, third, last. And we'll see the advantage when it becomes much more convenient. The second kind of data structure is called dictionary. So like what may happen, we can put, let's say, we are talking about the marks of a student in a class. Of course, we can make one array of the marks of the students. We can make one array of the name of the students, and we can always say, if fifth row, let's say, belongs to Sat, and then how much are the marks for the fifth element in the mark array, and we can relate it. But in the dictionary benefit is, in the dictionary index need not to be the integer only, like 0 1 2 or -1 -2. It can be a string itself. So here we are giving the example of rainfall. Let's assume we have rainfall in Delhi, rainfall is 0 mm. In Bangalore, let's say we have 5 mm. In Kolkata, let's say we have the 10 mm. Now if we want to know rainfall for Bangalore, we know this is the first element. So we can print rainfall 1 and you get the output 5 mm. But if we define this in the dictionary format, so dictionary is defined in the curly braces, you can see. So we defined first the index, which we are defining in the string format. So Delhi has value of 0, Bangalore 5, Kolkata 10. Now we can use index of in terms of index, this in terms of string. So like you are seeing, rainfall for Bangalore is 5 mm, or we can say, let's say, print rainfall of Delhi is 0. I find it very useful when, let's say, we are defining parameters for one single model. So you can make a dictionary for name of that model. So it's becomes very convenient. We are talking about the parameter of that model. We will, when we go deeper into Python, you will see. But this is very useful data structure. List is very common, and the dictionary is also very common. In fact, in this session, I have tried to list it only the which are very commonly used. There might be many more kind of data structures which at least I don't use regularly, so I have not listed it here. The another one commonly used is also, it's called tuple. Tuple is very similar to the list, but here is one minor difference. Will we go into it? So in tuple, we are not defining any square bracket or the curly bracket. We can separate the element with the help of comma. So we have three elements in our variable foo, 5, 15, 18. So it means three variables. Indices start in the same way, 0, 1, 2. So we can print foo2, which is of course the 18 value. But here one important thing is, we cannot modify any entry in the foo. So if we say foo is equal to 1, we want to change it from 15 to 10, we cannot do. It throws an error. So tuple becomes very useful when you want to define something which you don't want to be changed inside the program. So nothing can change it. It will throw an error. So whenever you have some constant or some variable which you do not want by mistake or in any way to be changed in any program, you can define it as part of tuple. So before you see, let's say if we had this as note the tuple, if we, let's say, it was some simple list, we can simply say, let's print foo1. Now let's say we want to modify it. So you see we are printing the foo1, which is 15. Now we have changed the value of first element from 15 to 10. So you can see now our list is 5, 10, 18 instead of 5, 15 and 18. So in the list, in the dictionary, you can always change the values, but in tuple you cannot change it. Now the question is, how do you define a tuple? We have only one element. So even if you have one element, let's say 5, you can you need to use 5 and then comma or any value and comma, then you can define that tuple. So like you can see here, we are writing 5 and comma, so it becomes a tuple. If we don't use the comma, then you can see in this example, then this is simply an integer. Another commonly thing used, which is part of the, not part of basic Python, but part of the numerical Python or NumPy library, is the NumPy array, which can be n-dimensional array. So you can have any number of dimension, more than one also you can have. So before we use it, we need to ensure whether NumPy is installed in our Python or not. If you are inside the Python, you can type it. If you are, let's say, I out the Python and you want to quickly check it, so you can type Python. So it's not giving error. So Python, when we say this hyphen and c with the space, we can quickly execute Python command which are just one line. So here we are testing import NumPy. it is not giving an error, it means NumPy exists in our Python library. We will work in Colab. We are working in Colab. We can directly type import NumPy and we can run it. And let's see if we get an error or not. So there is no error. It means NumPy is installed. Just to get to know what happens if it's not installed, we will use a library which is not installed. So it's giving error, no module named Ambas, so it's not installed. So we need to install. So if you have not installed NumPy, you can go to the previous sessions and you can install the NumPy, which is simply like pip install NumPy. You install it. Now we move to a part when we have NumPy. So first we need to import NumPy. Then let's start with defining a simple list. Like we discussed earlier, it can be a mixture of float, integer, or anything. Then we can define it is, so we are converting X list into the NumPy array. So the format is simple. X is equal to NumPy array. In bracket we can write whatever list we had. And let's try to print the type X. So you can see this is the NumPy ND array, means n dimensional array it is. If we want, we can print the value of X also, what it contains. So you can see all the values, because in our float we had only 9.0, so it's sorting it to 9 and it's treating all the values at the float. You can see the decimal point. Now you see the NumPy, it becomes very long name. Sometimes there can be library, then sub libraries, then sub libraries. So we can provide a short name which becomes more convenient to use. So in Python we can write import NumPy as, you can define any short keywords you want to select, which is easy to remember. Typically many people use import NumPy as NP, so it's easy to remember, like scientific Python as SP, matplotlib, so PLT. So it becomes more convenient if other people are reading your code or you read other people's code. So it's good to follow some convention, but it's up to you whatever you want to define. So same thing we can do. Instead of NumPy.array, now we can write np.array, and you can see the type, you can print the value of it. Sometime when we don't want to use don't need the entire library, we can also import one function from it. So here I am giving an example from NumPy import array functions. So then we don't have to define NumPy.array or np.array, we can simply write array. So this kind of import we do when we need just one or two functions from a library. Typically this NumPy, scientific Python, and the matplotlib, these are the commonly used library where we need many functions. So it's good to import them as import NumPy as np, import scipy as sp. Sometimes we use library, which you will see in the later examples. Then we can import single just one function what we need. We can also call import all the functions. So from NumPy import star means all the functions. Usually it's not a good practice to use this convention. Just for the sake of completion, I am covering this part because it becomes very confusing. You may have the similar kind of function, same function in different library, then debugging becomes very difficult. So it's good to give a short name or call the specific function so it's easy to remember. So it's not a good practice to do this, but it's up to you. If you want, you can do it. Nothing stops in this. So now what's happening here, when we have an array, so there are two part. One is the kind of array we have, one dimensional, two dimensional, what kind of array we have, and what kind of element we have inside the array. So here we are defining one array which is A, and we can use D type, which means data type, and you can see the output. So we are defining different kind of array. You see in the first one we have one float and we are printing the data type here. So it's treating everything as the float, 64-bit float. You can see the B here, everything is integer. So Python is treating it as the integer, or NumPy is treating it as integer. We have the Daily and Paris, which are a string, so it's treating as the string. Then you have the mixed array where we have integer, we have one string. Then NumPy is treating everything as this string. So if you have integer and float, it will treat as float. If you have some number and the string, it will treat as the string. So it combines, but it has the uniform data structure. NumPy array like list cannot have string also, integer also, float also. It will convert everything into the same kind of data point. So this is very important thing to remember. So if you have a text file where you have some number also, you have some text also, it's good to treat it as the list and then use it for processing. If you convert into NumPy array, your file will become a string. And just how it treat is, let's say if we have uh, we can say print 5 plus 5, it will print the answer. You can see the 10 last entry. But if I print D0, which is my 5, what do you expect now? What will happen? We have an error because this D0 is not 5, it's not an integer, it's now a string, and the string we cannot add 5. So this kind of error you will face if you convert a mixed list or mixed kind of entries into the NumPy array. You will have to be careful how do you treat it, what kind of operation will be later exported on it. In the NumPy we have many other functions. So like if you want to sum the variable, we can just type the variable name and sum, we get the sum. There are many other like you can use yeah, one more thing you can see, when we are clicking sum and we are defining the two bracket. So we'll not go into the object oriented programming kind of stuff, methods and attributes and those kind of things. But two things you can remember for simplicity. If you see, when we put c.d type, there was no bracket after it. Then when we do the sum, we are putting the bracket. So typically bracket means some input may be required, not always, may be required. Let's say you may say by default provide the sum of power 1 or square root or something like that, but there is an option you can change it also. So when Python is doing some computation after we run this program, so you will see this brackets are there. When something is already defined, you can just put a dot and you don't have to provide the bracket. So it's called methods and attributes. Sometime later we'll go into it, but maybe in the beginning it's difficult to know where to use brackets, where not to use bracket, but practice, with practice it will come. Let's try to see what will happen if we don't use bracket. Let's print it. So it's giving a reference to some some function. So there is no harm when you are developing your code. Even if you forget, not a big deal, you will see it's referring. So it means now you to provide the bracket, and you can provide bracket and you can see what is happening. Because there are well defined library, maybe you can remember, but every user can define their own library. So if I have written many libraries, it's not easy for any other person to remember what is method, what is attribute. And there are few libraries which you use again and again. Maybe you will remember like numerical Python, but there are few libraries you use once in a while, so it's not easy to remember. So not a big deal, don't worry about it. So that's it for the basics of data structure. With little bit touched a numerical Python library, which is very very important. Now in the next sessions we'll go more into it, and then see you. Yeah, thank you.